Hello, this is Martin, and we'll talk about the system services and what is important for the exam. So what I meant is to use fork in order to create a new process. Um, I will create a file, C file. I will first include all the important libraries. Standard input output, standard library in UniSTD, I hope that's correct. That's for using fork and exec instructions. All right, so I'll define a main function as integer, which means I should return integer at some point. And I will use a simple instruction to print the word hello, \n for a new line, so it's not on the same line all the time. And I will save it. I will compile it and I will run it. Good. Looks it's working. Great. So I'll go editing it again. And so we'll talk about fork. So what fork does, it creates the new process that will follow all the instructions below. So basically, here comes the process. We call the fork. I will use the letter F to do so. And a new process that is called a child process is created, and the old process is still running. It's called parent process. And they both will execute all the instructions below. So they will both print hello. And so when I now save it, compile it, and run it again, you could see we have 2 times hello printed. And one of the examples in the exam is to analyze the code and says how many times something is printed, how many blocked processes remains in the system, or how many running processes are in there. So let's do a couple of more examples. So I'll give one more fork here, and I will analyze it here. So here comes the process from the main function. There's one fork, there's another fork, and printing hello 1, 2, 3, 4. So if you're asked how many times hello is printed, you're gonna say 4 times and you'll be right. So just to prove it, it's really 4 times. All right. Obviously, if we added one more fork, it would be 8 times. But it may get a bit more complicated. One of the other instruction that is necessary to know is called pause. Pause will block any process that comes in. So in this case, it will block all 8 processes. All right. And then it will not print hello at all because none of the processes will remain there to execute the print. So just to see in a print, in a drawing, we've got a process, we've got the first fork, we've got a second fork, we've got a third fork, and then there's pause, which will block all these processes. So if you are asked how many times hello, it's 0. If you are asked for how many blocked processes, it's number 8. How do you say it's blocked? You may actually see that. So when I run the system services now, so I'll compile it again and I'll run it. First of all, I'm blocked. I can't really do anything. But if I run it in the background and check for that process by the name, you could see them blocked. 1, 2, 3, 4, 5, 6, 7, 8. Okay. You may terminate the processes with signal number 9. Wouldn't work. Never mind. There's surely a better way of doing this. 2 already comes to my mind, but I'll finish it this way. And finally, all right. So that is instruction pause that will block the processes. Another thing that may appear in the exam is an if statement with comparison to 0. So it may look like this. For example, let's not give pause in there. So let me analyze it first. All right, maybe first we should mention what the if statement is. So the instruction fork inside the if statement here will really happen. Okay, so this will double the processes. It's not like it's not happening if it's in the if statement. It's a function that is being called here. But we compare it to 0. And what this task is about is that when you create a child process, let's this be the child, it has a return value that is equal 0. It's like true, like it was successfully created. While the parent process here will have another return value, which is the PID of the child process. PID stands for process ID. So what I'm saying here with the example is that there comes the process, there's an if statement in which you do the fork, but one is equal to 0. Let's say it's this one. So it goes to another fork and prints hello. The other one is not equal to 0, so it just goes like that till the end. If there was another instruction, it would do the instruction. So now it's gonna be 2 times hello, and that's it. Okay, we can demonstrate it quickly. One hello, second hello, and the other process haven't finished yet. All right. What else? So let's make it a bit complicated. Let's play with what we already know. So let's say we add pause here, and we have some printing here. So let's say we're gonna have high. Let's keep it lowercase. Great. All right. So now the question is, how many times hello, how many times hi, and how many block processes there are on the system? Okay, so we start with the fork. One will go into the if statement, which is the fork, and then hello and hello, and then it's blocked. The other one will go, and say hi, and that's it. So we have 1 time hi, 2 times hello, and 2 block processes. Okay, let's make it a bit more complicated, even that. So let's say there's no pause here. There's gonna be pause here. And printing by. All right. So again, we start the if statement. One will go to the if statement, make a fork, say hello, hello, then it goes on. It's not paused. Here we go. Hi, 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 and then it's paused, and nothing will happen after that. So we have 2 times hello, 3 times hi, 3 block processes, and 0 by. All right, let's do the last one. Let's go with looping another fork in it. and removing this one. And let's have one fork in here. This is gonna be removed. All right, let's do this one. Good. So we have a fork. Then there are two processes coming to the if statement. They will go to fork, but only two of them, those child processes, will be equal to 0. The rest of them will just continue here. And those two processes equal to 0 will enter the if statement where there's another fork. And only those child processes will print hello. So here's hello, and then we continue. We continue after hello as well, and we print hi. So we have 1, 2, 3, 4, 5, 6 hi. We can verify. Let's compile it and run it. So we have 2 times hello and 1, 2, 3, 4, 5, and 6 times hi. All right, so that's correct. Let's do one more, last one, just to be sure we have the understanding. Let's go with pause here. It's gonna be interesting. So we have a fork. Then we have another fork in the if statement. And then two of them, those child processes, will go inside the if statement and will be blocked at the very first instruction. The other two will continue and will skip everything in there except the hi and hi. So I hope I'm right. I think it's 2 blocked processes and 2 times hi. So we can give it a try. Yes, we have 2 times hi, and if we checked for the processes, we would find 2 blocked processes in there. All right. There's one more thing I want to share. Mm. And that is exec. Exec works a bit different. So when you when a process comes to an instruction with exec, whatever you exec in there, like sorry, I'm gonna write something in there like command pwd, for example. It's gonna be executed. Whatever is inside is gonna be executed, but it will not create a new process. Like the exec will overtake this process and run something. So it's not gonna be a new one. So let me demonstrate it. I'm not sure I can do it. I haven't done it for uh, quite some while. So maybe we'll do some Googling. So this is the exec instruction in C programming. And let's say we say ls command. It's gonna do like that. And now it's the hard part. I'm not sure I remember it correctly, but we'll see. And the semicolon could be like that. It's not important that you remember it or something. I don't even remember it. I'm not sure it's gonna work. So you're running exec, and you're gonna be asked like how many times this ls command will be executed, right? So since we have fork here, so two processes will come here. I believe the ls command will be executed twice. Let's check. Um, Now the moment of truth. Oh mine, it's working. Didn't expect that. All right, I have something in there. I'm not sure how to. Yeah, it's twice. So everything here is 2 times. Perfect. Right. So this is the exec instruction. It's not. It does not create a new process. So whatever comes here, like hello, let's say, I'm gonna print it here. You may guess how many times hello is printed right now. And you could see, well, there's none such mention. All right. So what happened is, as I drew here, so the exec overtaken the process, and whatever came after, there was no process to take care of it. So that's how the exec work. Uh, we may do some more examples. So I'm gonna run something more simple. Let's say pwd, and which will return the current location. Where am I? The path in. Let's say I'm gonna go for one more time, and I'm gonna say if fork is equal to 0, then exec, and yeah, this is sufficient. So we're gonna be asked how many times hello, how many times pwd is printed on the standard output. So let's analyze it. So we have a fork, we have another fork, and we have another fork in the if statement. And only the child processes will enter the if statement and do the PWD. So the child processes in here. So we have 4 times, and the rest of them will continue, will continue, will continue, will continue. This will not continue because it's overtaken. So nothing like that. That's the game over. And we have hello here, hello here, hello here, and hello here. So to me, it seems like 4 times a hello and 4 times a PWD. Let's give it a check. Yes, we have 4 hello here and 4 times the current path. That's perfect. And the last thing we can try is to add the while loop somewhere in there. Um, I need to be a bit clever to not loop the fork process. Otherwise, I do something that's called the fork bump, and it would kill my system totally. So let's say, yeah, maybe let's keep it that way. So if you enter a loop in here, it's actually not gonna do anything special. Um, it's all about if your processes are running or ready to run and so on. I can demonstrate. Right. So we have the exactly the same result. All right. Uh, that's it for the system services. If I have something to add, I will record another video. So far, I think this is enough for the exam that we have. Good luck. Take care.